Hello Year 10, today we are looking at the respiratory system again. We're going to be looking at aerobic and anaerobic respiration. So we're looking at the way our body produces energy. Before we start, I just want us to note down and know that there are two different types of respiration that will occur within our bodies. The simplest way to think about these are aerobic, which we're going to be looking at first. Now, we know already that if somebody is doing an aerobic type of exercise, that they are using oxygen. So aerobic respiration very simply means that we are able to create energy whilst using oxygen. So the equation for aerobic respiration is glucose plus oxygen. Let me draw the little plus sign in. Glucose plus oxygen equals energy. Energy is not the only thing that is created during aerobic respiration. We know that there is a byproduct. That byproduct is carbon dioxide. The final thing that is also created is a little bit of water vapour. Now, a couple of lessons ago, whilst we were looking at the way we breathe and we were looking at the composition of air, one of the things that was noted was that when we exhale slightly more water vapour. That's because one of the byproducts of aerobic respiration is water. The next type of respiration that we're going to be looking at is anaerobic respiration. So you can see here I've actually underlined anaerobic, and the reason for that is because I want you to know that anaerobic respiration means without the presence of oxygen. So when we are using anaerobic respiration, all our body needs is glucose. That glucose is then converted into energy. Along with energy, we also get a byproduct. This time our byproduct is slightly different to aerobic respiration. It's called lactic acid. Now, for any of you or think about a time when you've done something that's really explosive, like a sprint. As you approach the end of that sprint, you'll feel your legs starting to seize up. That's due to a build-up of lactic acid. Now, that can obviously be quite harmful to you whilst you are running, and I don't mean harmful in the sense of dangerous, I mean harmful in terms of performance. If you get a build-up of lactic acid, it will start to cause cramp and prevent you from continuing. The final thing that is produced during anaerobic respiration is water. Now, we've seen this already with aerobic respiration, and it's exactly the same, where our bodies just let out a little bit of water vapour. Now we know what anaerobic respiration and aerobic respiration are, I now want us to look a little bit more closely at the type of athletes that would use each type of respiration and when. As we've stated, both types of respiration will be used for different athletes and at different times. So looking specifically at anaerobic respiration, it's likely to be utilised by somebody that's doing quick explosive movements. This could either be a burst of power, such as long jump, or it could be a sprint. Normally, somebody who is using anaerobic respiration will be performing without using any oxygen. So that could be something like a throw or a jump, any of your field events during athletics. The other type of respiration that we've looked at is obviously aerobic respiration. So with any athlete that's using aerobic respiration, they will normally be working for much longer durations. So this could be somebody like a marathon runner, this could be somebody that's like a cyclist. So we know that the time period that they are using that energy system for is over a prolonged period of time. Now, I want to make this very, very clear. Just because an athlete is using explosive movements, or just because an athlete is using or is performing for a long period of time, that does not mean that they can't dip into the other energy system. An example of this would be my cyclist. If I take my cyclist who is performing in the Tour de France, whilst they are performing on a flat surface, flat roads, they will be using predominantly their aerobic energy system and aerobic respiration. However, as soon as they go to something like a hill sprint, where they're going to be needing to be going uphill as fast as possible and there's a much higher resistance, they will then be dipping into their anaerobic energy system. Once they have had that burst of power, They will then need to take in a higher level of oxygen to repay the oxygen debt used whilst they were performing anaerobically. Another example of an athlete who would be using both energy systems at once would be any games player. This could simply be a footballer or a netballer. Whilst they are just maintaining their pace and performing, i.e. running up and down the pitch, running up and down the court, they will be using solely their aerobic energy system. When they are chasing down a player or maybe defending, that's when they will be dipping into their anaerobic energy system as their movements become more explosive. We now know the different components of the respiratory system. We know how we breathe. We also now know what gaseous exchange is. And the final part we have learned is how respiration actually takes place. The final missing piece to our puzzle is knowing what the effects of exercise are on our bodily systems. So what that means, if I'm doing exercise, how does it impact my body? How does it impact my cardiovascular system and my respiratory system? That's what we're going to be looking at, and you will find out today. There's two key terms that I want us to get down. The first one is short-term effects on the respiratory system, and the second one is long-term effects. Now, when we are looking at the short-term effects of exercise, it simply means what happens to our bodies as soon as we start or finish exercising. So, the first thing that we know is that we have an increased breathing rate. That means that we are breathing more so that we can get extra oxygen into our bodies and to our working muscles. The second thing that happens is that there will be an increased depth of breathing. If you think about a time when you've participated in some sort of activity, as soon as you started, your breathing will get deeper. That's again because you need to increase the amount of oxygen that you can take to your working muscles. And finally, there will be an oxygen debt. As we've just discussed, this will only be relevant if we are doing anaerobic activity. If somebody is participating in aerobic activity, it's not likely that their body will use excess stores of oxygen to break down lactic acid. Long-term effects on the respiratory system are what happens to our respiratory system once we've been training for a long period of time. Now, this could simply be that you've been doing circuit training over your lockdown period twice a week, or this could be that you've been running 5-6 days a week for the last 6 weeks. What our long-term effects are is what happens to our respiratory system once that training has taken place. So we know that we will have an increased number of alveoli. So the more we work our respiratory system, the more alveoli we will have. The reason for that is because they increase in size so that they can cover a larger surface area so that gaseous exchange can take place at a faster rate. That will obviously aid performance as the delivery of oxygen to working muscles can happen quicker. With this, there will also be an increase in capillaries around the alveoli. Again, exactly the same concept. The more capillaries that are there, the quicker the rate of gaseous exchange can take place. And thirdly, there will be an increase in tidal volume. So we know if we are exercising for long periods of, or not even for long periods of time, if we are exercising regularly, it will benefit us in the long term by making our respiratory system work more efficiently. Thank you very much for sitting out all 3 of these lessons, guys. If you need any help or any support, please feel free to either email myself or Mr. Tuig. Good luck filling out the forms and get started.